Hello, my name is Muhammad, and in this lab or in this video, I'm gonna explain the wireless system, the whole steps from 1 to 14. So, hope you enjoy. Let's get started. First of all, in step 1, this setup ensures that host A will continuously send UDP. So, here is two hosts communicating wirelessly. The description of the step 1 and the UDP packets to host B at a rate determined by the exponential distribution, and host B will receive these packets. So here, as you see, the UDP and host B, and the packet name is UDP data, and the wireless communication is modeled with a unit disk signal representation and a fixed communication range, ignoring interfaces. So here, the ignore interface is set up to true, and which simplifies the simulation environment. Let's go and try to run it and see the simulation, how it goes. It may take some time because I close my laptop and I restart it again. And the result, we're gonna see the buckets transmitted back to back. It's gonna take a while, and this video gonna be so long. Also gonna explain here the wireless from step 1 till 14, and inshallah it goes as we planned. Okay, finally. Let's choose here step wireless 1 to host. No, okay, this one. Let's go. Here we have the host A and B. Let's run them and see. As we see, there is no gaps between the subsequent packets. Also, for this we're gonna analyze the signals, which is gonna be as a result at the end. Okay, and here the bucket distance 5. I guess there is no need to watch all of it. Okay, let's copy. Start to copy here. I'm not gonna analyze all of them because I already have done that on ChatGPT, and I copied also the codes. Let's just give him this. Okay, Control C. Where is my ChatGPT? Okay, ChatGPT. Go ahead. How many packets were received? Okay, here it tells you 1595, and we can ask him many questions, and here the explanation, the analysis of it, packet delivery is UDP data 6, and here I was giving him also the codes to to see and to explain for me so I can do the video as we see here. I'm not gonna come back to ChatGPT again. It's gonna take so long if we did this. Now let's finish this one. Okay, that's enough for you. And go for the result. Where is the result? Okay, wireless. The wireless. And here the result. Wireless, okay. So this one. Finish. Okay. Browse data. Bucket sent. To see the bucket sent count and see the chart for it. Okay. Chart. More chart. And Python script. As I said, this video gonna be so long. This is the charts as we see. Now we need to save. Now let's go to configure wireless 2. She's in step 2. Basically, the additional settings in wireless 2 focus on enhancing the visual representation of the simulation. By enabling these visualizations, you can better observe and understand the communication dynamics between the hosts. As we see here, all are set to be true. Here true, which is the visualizer display links, and here it's true. Setting up some animation. Here communication range is true, so it's gonna show us some range. Let's try to run it and show the simulation of step 2 while we it's better to explain also the step 3, I guess. So in step 3, here is wireless 3 configuration builds upon the visual enhancement and basic communication setup from wireless 2, which is from here. Wireless 2, every step is just enhancing for the step previously, and which reduces the communication range in all nodes to 250 meters. And here the display communicator range is true as well. This is basically for step 3, that's what it's saying. It extends for wireless 2. And still it's not running. Okay, also in step 3, the result gonna be when we run the simulation, blue circles confirm that hosts R1 and R2 are only hosts in communication range of host A. Therefore, they are the only ones that receive host A's transmission. We can see the, for example, uh, let's run for step 3 and see what's going on here. Is it already done or not? I don't know why it's taking so long, but I guess also finally not this one, we need this one. Okay, let's run step 3 and see here what's gonna go on, what's going on here. Okay, here the ranges. Okay, configuration, and the radio is medium. Let's run, and here the blue circles I have mentioned. which is confirmed that hosts R1 and R2 are the only hosts in the communication range of host A, which is here, ranges. I guess that's enough for this. Okay, no, finish. Got to do finish. We need to finish. Come back to our. Okay, what is the result? Here we have. Okay, here we go. Finish. Let's go and see the bucket sent. Or bucket. Let's this time see the bucket receive bucket receive count and wash out. As we see here, there is nothing. Maybe because I didn't finish the. Yeah. Okay, let's do. Don't save. Don't save. Let's go to. Did I haven't explained step 4? Okay, let's explain step 4. Basically, in this step, we set up routing so that packets can flow from host A to host B. Also, here is extending from the step 3 and setting up static routing. So the wireless 4 configuration builds on previous setups by adding static routing and enhancing the visual representation. I already have mentioned that. Uh, and uh, and some of the changes gonna be enabling bucket forwarding. Here is basically we enable it by true, and the optimization of routes is gonna be false, and clearing the existing net mask here, and adding visualization. So here basically is true and true for the visualization, and here unless I should have run it before so we don't lose time. Also here let's explain step 5 as well while we are waiting for step 4. No need. Already it was run fast. Step 4. Okay. Here we see the ranges. Let's run them. As you see here in the result, when the first bucket sent by host A arrives at host R1, a dotted dark yellow arrow, which is this arrows, which is in yellow and purple and this stuff, appears between the two hosts, indicating a successful physical layer exchange. And here the ranges. Bucket received till now is 3. And here we can take this signal and give it to ChatGPT and ask in which any line we can indicate. Okay, let's finish this one. Buckets received as we see 807 in time of 20 seconds. That's enough. Finish has been okay. Thank you. Here let's run while I'll run it. No, no, let's come see the results. Yeah, I forgot the results. Let's come see the results. Yeah, for wireless for. Okay, finish here. Impulse and browse data. Bucket sent. Bucket sent count. Yeah, let's see here in the bar chart. Here's the chart as always. Don't save. No need for that. And here wireless 5. Let's run and explain wireless 5. Okay, in the wireless 5, basically the configuration builds on the previous setups. As we mentioned, every step is like no need here. We're gonna come back. We're gonna come back after. Um, every step gonna come like and do some changes for the step previously. So here it's gonna be doing some changes, and after that in step 6 gonna extend to the step 5, and here is extending for step 3, and till the end it's gonna be the same. Here we are in step 5, which is introducing interfaces into the simulation. Also, which adds a layer of realism. It's gonna be more realistic. It's gonna be more realistic in this one. And also the bucket filter. We set it here. Okay, let's go and run. We were in step 5, I guess. And we see the result of the step 5. Let's run it. Okay, as we see in the results, host A is transmitting the buckets generated by its UDP application model, and R1 is at the right position as well of to act as a relay between A and B. Is A, is B. There, the R1 is in the middle, and it transmits A buckets to B. So just gonna take the buckets from here to there. As soon as receives them. Okay, I guess that's it for this one. It's enough. Do we finish? Yeah. Okay. Close this page. Back to our page. No need to show the chart. Let's just go to step 6 here, and we explain step 6, which basically standing for step 5, as we said here, and which is implementing the CSMA here, CSSMA and the CA MAC protocol to manage medium access and and improve overall network performance. The key changes which are changing the MAC protocol to CSMA and CA. As we see here, the bucket capacity is 1. That's it, I guess. I forgot to run. Before I explain. Okay, let's go to bucket 7 to explain it. While no need. Okay, we go to 6 and run it and show the simulation. Okay, result of dropping the drop tell K, the first two packets are sent by host A, as we see here, sending the packets from host A, and after waiting for a backup period, host R1 retransmits the both packets after it arrives here for the host R1, send it back, and this time host B receives them correctly. This B receives all the packets correctly, which packet received from wireless B, which is 3. Let's see how much gonna receive, how many packets. Okay, the packet received 810. No, not 810. 1069. Okay, finish. That's it. And here in step 7, now let's run and then explain. Run and wait for wireless configuration builds on the previous setups, which is I had mentioned that before. Here the wireless steps, which is step 6. Every step is just an extending for the previous step, which is enabling the AC keys in the CSMA. Let's run step 7. I see. Okay. Ensuring the packets are successfully received. Run. The results with the AC keys, which is enabled. Here, enabled. If we come back here, the Mac use AC key is true. Basically, the code is that. There is nothing else. So the result, which is the AC keys enabled, is successfully received. That means everyone gonna receive successfully, all of them correctly. Which is bucket is acknowledged. Let's finish this one and see how many packets received. Also, we can simulation time. Yeah, okay, packet received 1047. Finish it, and let's go show the chart. Okay, for here the result for 7. Let's show the chart here. Okay, and here bucket sent count. It's gonna show us the chart. This is the chart basically. No need to save. Let's go to step 8. Step 8. Do we have to? Step 8, which is the modeling energy consumption, and here is just extending for step 7. As we see here, the which is circular for simulation focus on battery life, which is here battery energy consumer, and the management in wireless, and the changes are, as we see here, we have many changes, and energy consumption with the state based by energy consumer here, power consumption, sleep and switch and receive, and transmitting using an idle energy here. I've set them milliwatt, all of them, the busy also as well, and also using an ideal energy storage model, where here ideal energy, and that's it. Also, yeah, the transfer of power conservation also here. This which is we set them here of one milliwatt and all that, and here we have the energy storage which is ideal energy storage, and that's it. And here the radio display we set it up as false. Let's run and see. And here the ideal energy storage. As a result, we won't have something that much. Okay, let's go. Wait, video gonna be so long. Let's run. As we see here, host A is sending to other host. First of all, it is sent to R1 and R1 after receiving it sends to the others. That's it for that. Now let's go to step 9. Okay, that's enough. Let's go to step 9. She builds on the previous setup. She's here, right? Configuring the node movements and adjusting the bucket queue capacity and enhancing visualization and changes. We're adding mobility to nodes. Here we have mobility to nodes. So here the movement, she's setting up movement heading. The capacity is 10, bucket capacity is 10 as you see here. So let's run and see. And here the display of velocities and movement range which we have set it here true and true, it's not false. So we're gonna see how it's gonna be on here. And we explain 10 and yes, okay. Step 9. Configuring node movements. Let's see the node movements here. As we see here in the result, it can be seen in the simulation below as host R1 leaves host A communication range. Also, I can show that in the animation. If we go to the website, they're showing that he's gonna leave to the top around 11 seconds. Also, the communication path is gonna be broken. If we try here to make it faster, as you see here, the current velocity. So it's taking so long. Let's just see, as you see here. I was waiting for this, but the host R1 broke the path and went up, and also the two rows, which is host R2 and host R3. All the R1s they broke the range and went up. Okay, that's enough for this one. Let's go in the result and show step 9. Step 9. Step 9. Where is about data? Pakistan. Pakistan count. Okay, here we see the bar chart. That's enough for this one. Don't save. Let's come to configurator 10, which is configuring ad hoc routing or ODB. As we see here, the packet filter is ODB, and the type name, which is enables dynamic route discovery and maintains. And as we see here, the changes configures all hosts of ODB router enabled. And here the add static routes is false, so it's not true. So it's not gonna use the add static, which is just ODB protocol. Let's run. Let's run. Here's step 10. And see the simulation of step 10. So here's step 11 to step 10. No, step 10. Okay, run. As a result, here we're gonna see the host R1 moves out of communication. It is gonna go out for the communication range and host AB. The route that was established through R1 is broken, and hosts R2 and R3 are at the right position. To rely for host A's packets to host B. ODB protocol recognizes recognize the route to go through R2 and R3. Okay, let's packet save still now is 4. Let's just, because it's not gonna. Okay, as we saw here, host R1 and R2 they block the path, and that's it. For this one, let's finish it. Okay, let's go to step 11. She's adding obstacles to the environment. She's just extents of step 10, and the the obstacles to the environment affecting the wireless communication between nodes. And here, as we see, configuring the physical environment with obstacles. Here, as we see, which is was XML file, and here the ideal obstacles. Let's run. Let's run. Here, mobility initialize 1.7. As we're gonna see in the result, the wall is completely blocking transmissions. You can see the wall is blocking the way. Therefore, the ODV establishes the AR2. Where were we? In step 11. Okay, let's run and see. Also, host R2 is gonna be cut the transmission of host R2 and moves behind the wall. This is gonna take so long. Let's just skip and see at the end. Okay, as we see here, host R2 goes up, R3, host R1. All of them, and packet received are 475. And let's finish. Okay, that's enough. Let's go to step 12, which is extending to step 11 and the description of changing to more realistic radio model. It's gonna be more realistic. And here it's gonna be enhancing the IBCK radio model and adjusting various parameters related to signal representation. And here, as we see here, the center frequencies to also the bandwidth. Here the transmission power is also 1.4 milliwatt. And here is 10 microseconds, which is the preamble duration. Header is 8p sensitivity, all of that. And here the result recording, which is gonna be default. Let's run. Also here in step 13, should I explain it while? No, let's wait. Okay, that's good. Let's see here the result. Are we in, yeah, in 12? Let's see the result here. Let's run. As a result, what happens is about the same as in the previous step. So just they're gonna go up in this step and the previous step, which is 11 and 10, is going up and broke the path of sending the packets. They all went up. And packet receives is 307. Let's finish this. It has been finished already. Okay, the configure wireless 13. She's just extended to, as we know, the previous step of this step, and the path loss modeling in the simulation by using 2-ray. Also, as well, the ground reflection model and the physical environment ground should be considered flat. Here, the ground is flat ground, and here is 0. What does that mean? It's gonna be at simplifies the surface of a flat is gonna be sea level. So here is just sets to the sea level 0, and here the two ground reflection. Let's run. And in the result, which we just gonna see the bit error rate is shown when free space path loss is used. So we're just gonna see that. And then when using the 2-ray, well, the 13 here, 13. Let's run it. I don't know how many minutes for this video, but I don't think so. I'm gonna be able to upload it to YouTube. But if you are seeing the video, that means it's uploaded on YouTube. If I couldn't, I don't know how to upload it. I guess I have done 20 or 12 minutes. Also, must skip this one. As we see here, all the same. They went up, and path loss is used as well, and packets received is 420. And if we come and took the signals and put them in ChatGPT, we can ask some questions. ChatGPT, and let it explain for us. For example, let's see here the result of 12. I solve here, finish, and buckets and let's see the chart. Okay, here we have the chart. Don't save. Here, in the last step, the wireless 14, which is it introduces antenna gain. Introducing the antenna gain, it's just extending to step 13. Here, providing a more realistic, it's gonna be the most realistic one in the steps, I guess. And representation of antenna behavior. Connect here the constant gain antenna. And here the antenna gain is 3, as we see. So we see the antenna model, the last one, using antenna gain model. Okay, let's see the result. Actually, in the result, we're gonna see the added antenna gain and the transmissions are powerful enough to require only two hosts to get the host B every time, as opposite to the previous steps. This one is the most opposite one, and will sometimes require three, not one or two, three of them. As we see here, let's finish it. We see sense here, then sense host B. Let's finish this one. As we see here, it goes up as well. In event 7, 5 words, 20 seconds. Your bucket receives 879. And this is the last step. I hope you enjoyed watching. Let's run this step. Why not? I mean, let's show the shot, not run. Fire, bucket, bucket sent. As you see, the shot is also the same. With the wireless C host A. Okay, that's enough. Don't save. Hope you enjoyed watching the video and the explanation of the steps thoroughly from step number 1 till step 14, and I have shown how we run and the simulation and the result of the simulation, and that's it. Thank you for watching. Please stop the recording.